Next, last section of this chapter, real numbers, that is about decimal expansion of rational numbers. Here, three theorems are there. In that theorem 1.5, fifth theorem. Okay. Statement is like this. Let x equal to p by q, where q is not equal to 0, to be a rational number such that the prime factorization of q is of the form 2 raised to m 5 raised to n, where m and n are non-negative integers, then x has a decimal expansion which is terminating. That is, if x equal to p by q, that is x is a rational number which is of the form p by q, and q, that is denominator q, if we are able to write in the form 2 raised to m 5 raised to n. 2 raised to m 5 raised to n means it's a product of that 2 and 5, where m and n are non-negative integers. If you are able to write in that form, either 2 raised to m into 5 raised to n, m and n can be non-negative, means it can come as 0 also, 5 raised to 0, that means no 5, only 2. So, if you are able to write q, that is denominator of the given rational number, can be able to write in the form 2 raised to m 5 raised to n, then that x has decimal expansion which is terminating. Rational numbers decimal expansion is terminating. This is theorem number 1.5. Theorem number 1.6 is the converse of 1.5. Then you can read from the text. Now the last theorem of this chapter, that is theorem number 1.7. That is like this. Let x equal to p by q, where q not equal to 0, be a rational number such that the prime factorization of q is not of the form 2 raised to m 5 raised to n, where m and n are non-negative integers, then x has the decimal expansion which is non-terminating, repeating. If x is a p by q, which is a rational number, then that rational number in that denominator q, if you are not able to express in the form 2 raised to m 5 raised to n, if you are not able to write as the product of 2 and 5 or exponents, okay, it's not possible, means its decimal expansion is non-terminating, repeating. We know that rational numbers has decimal expansion either terminating or non-terminating, repeating. When it is terminating, if the denominator, if you are able to express in the form 2 raised to m 5 raised to n, then it is terminating. If it is not in the form 2 raised to m 5 raised to n, it is non-terminating. So these are the three theorems in that the last section of this chapter. Question number 1 of exercise number 1.4, the last exercise of this chapter, based on the three theorems we have discussed just before. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. So, without actually performing the long division means, so these are the questions given, 13 by 3125. Without doing the division, we can tell whether these rational numbers have which type of decimal expansion, whether it is repeating or non-repeating, terminating, okay, which type of decimal expansion, whether it is terminating or non-terminating, repeating. How can we do that? We want to find out whether the denominator can be expressed as 2 raised to n into 5 raised to m, or 2 raised to m into 5 raised to n. If it is possible, then it has terminating decimal expansion. If it is not possible, then it has non-terminating decimal expansion. Answers of that questions. In that first one, 13 by 3125. Here 3125 can make it as or factorizing, we can get the answer as 5 raised to 5. So now the denominator is in the form which type? 5 raised to m. 2 is not there, but 2's power is 0. That is possible, okay. So hence the decimal expansion is terminating. Second question, 17 by 8. Again, denominator, take the denominator 8. 8 can be factorized and get as 2 cube in the decimal form, in the exponential form. So the denominator is the form what? 2 raised to m form. If the denominator is in the 2 raised to m form, then it is as terminating decimal expansion. Fifth question, 29 by 343. 343 can be rewrite as 7 raised to 3. So the denominator is in the form, is not on the form 2 raised to m into 5 raised to n, because since 7 is coming as a factor. So the decimal expansion of this number, given number, is non-terminating repeating. Sixth question, 23 by 2 raised to 3 into 5 raised to 2. The denominator is of the form 2 raised to m into 5 raised to n. Hence the decimal expansion is, it is in the form, it is already given itself 2 raised to 3 into 5 raised to 2. So it is terminating. Seventh question, 129 by 2 square into 5 raised to 7 into 7 raised to 5. Is the denominator in the form 2 raised to m into 5 raised to n? No. Here 7 is a factor coming, so it's not terminating, repeating decimal expansion. Eighth question, 6 by 15. There want to do 6 also want to factorize 2 into 3 and 15 3 into 5 and at last 2 by 5. So when we are doing these type of questions, you have to find whether any common factor between the numerator and the denominator. If it's there, you just do the cancellation. After that only want to check the denominator. So the denominator is of the form 5 raised to n. So the decimal expansion of this number also, it is terminating. So again two more questions and two extra, again 2 more questions are there, 4 more questions are there in this exercise. You have to do by yourself. That is the end of this chapter. Thank you, students.